All right, so I guess we'll go ahead and get started. Welcome. It's not a big crowd today, but hey, that's good. Nice, intimate little talk. So
some quality rather than quantity.
That's right. So this is the College of Education Research Colloquium. Happy to have you here. Our presenter today is Anita Roychoudhury, who's got, as most of you probably already know, an NSF project that's looking at children's conceptions of climate change, and she's going to talk about teaching climate change in the middle school. So I'll turn over the time to Anita.
Okay, thank you, and thank you for coming so late on Friday at the tail end of the week. I know everybody is meeting out or some other work have overwhelmed you, but anyway, I'm going to talk very informally, so feel free to stop me at any time and ask me questions. And also, you will find there are things that I have not talked about here, just to keep it short so that you can ask me questions. And I have, if you have any questions about what the instrument looked like and things like that, you can take a look. So I have hard copies of that. And as I said here, this is based on a paper that is in review, and my co-authors are Dan Shepardson, Andy Hirsch, and Dave Nyogi. They didn't take part in preparing the PowerPoint, so I did not make them responsible for this, but they have a copy of the PowerPoint. So if they have any objection to anything I'm saying here, they'll let me know and I can pass it on to them. Here is a co-conspirator. I was telling them that you're not responsible for my mess in the PowerPoint, but you have a copy. So here he is. And Dev is
I'll
with...
get you for the cookies.
Yes, so am I. And Dev is with a minister from Bangladesh talking about climate issues. So anyway, Andy didn't know this was happening, so he now knows, and I don't know if he can come. Okay. I'm going to talk about the literature very briefly, and Dan can fill you in a whole lot more about all the studies and other studies that he looked at. I looked at some. Basically, understanding of climate and climate change requires an understanding of a very complex system. And that in and of it is a major challenge. Research on climate change education is in its infancy. Very few people have actually written about that. At the moment, NSF has many grants out, many people are studying, but not a whole lot of people have published about what needs to be taught, how it needs to be taught, what's the outcome of having taught certain things. That research is still very sparse. Most of the studies that I'm familiar with are on global warming, greenhouse effect, and very few have touched on climate change. And mostly they have looked at what students do not know and what they know. Dan, please feel free to chime in about other aspects of climate change education. Very recently, Maryland School District has adopted climate change in their curriculum, but they are still working on what should be taught exactly. I just ran into one of the researchers from that project at NSF last week, and he said we are still planning and planning. So anyway, that gives you an idea how little is known about teaching at this point. And as I said, that most people have looked at, those who have looked at student outcomes have looked at greenhouse effect or biodiversity. Some people are looking at carbon cycle. Dan knows them very well. Just kidding. So anyway, that's the context of this study. Before we go into, how students did what we did, I would like to talk about some facets of research on teaching in classrooms. Researchers, those who study teachers and study curriculum implementation, they point out that teachers mediate what happens in classrooms. So no matter what we teach them or what we develop with them or what we expect them to do, what happens in classroom goes through how teachers interpret or how they implement. So teachers mediate everything that happens in classrooms. And this mediation by teachers of the curriculum depends on teachers' content knowledge and their pedagogical knowledge and students, their knowledge of students, how and what their students can do. And that is very context specific. By context, I mean school context, district context, that particular classroom context, and so on and so forth. So as a result, looking at teaching as here is the material and this is how implementation should be is a very simplistic way of looking at teaching. So adaptation, curriculum adaptation is something that needs to be considered. So that is one of the aspects of our theoretical framework. So we looked at teaching or teacher implementation as tool use and mediation. This is Vygotsky's idea about how teachers use things in classrooms and how students learn. There is a lot on that, and I'm not going to go too much into it at that point of time. So basically how we view this is teachers have these tools and they use the tools according to how their context is. So in this context, teachers are helpers, and instead of they are giving something, pouring something out, they use the tools to help the students to learn. Now, on top of the mediation issues, there are lots of issues related to science, learning and teaching of climate change. According to several researchers, learning science is essentially construction of a story. Not a story in the sense of a literature, but it's a coherent body of knowledge. All people who are used to teaching science and mathematics know that science builds hierarchically. So whatever is taught on one day, the next thing that is taught is based on what they learned before, and there are many cases, different units, the way we chunk lessons in classrooms, they have to relate to each other. So coherence is a very, very important thing, and scientists and science educators know that. So, but that makes it challenging also because students have to learn to connect all these different things they are learning. So that is thread that has received a lot of attention in current literature, that coherence of knowledge. There is a new science, K-12 science teaching and learning framework. I'm saying the name incorrectly, but I can send you the reference if you want. It's the framework that basically grounds the next generation of science standards, and coherence is a major theme in that framework. So those are basic science learning or essential facets of science learning. Now, looking at climate change, the context becomes even more complicated because climate change, and I learned a lot of that as we did this. Coming from physics, I had more really simpler things that we teach in physics in that regard, because the interactions among Earth's spheres, it's mind-boggling. And then feedback loops. And then the loops can be positive and negative. It is just astounding what climate change involves. And Dan pointed out many times to me, because I said, oh, atomic structure. He said, oh, that's simple. And sure enough, I now fully appreciate how complicated climate change is. So, given that context, we looked at two primary research questions. And there are lots of sub-questions which I won't go into. One simple question we had was, what's the implementation of the things we did? And I'll talk about that a little bit, what we did and how we did, in terms of curriculum or curricular materials. So these are the curricular materials for the implementation effects on student learning. And then we also wanted to look at teacher adaptation, because that was our theoretical framework, that teachers always adapt what they learn. So this was our design, quasi-experimental. We had an intervention group and a control group. I'm not going to talk about control group comparison because that was not a major part, but I'm going to talk about the results from intervention group because that is complex enough, and that will take me a while to go through all kinds of issues. And the participants were 11 teachers from 7th and 8th grades from rural and urban schools. Majority of the students, of the total body of students, were on free and reduced price lunch, which means they come from fairly disadvantaged family background. And some of these disadvantaged students were also ELL, so they were like a double whammy in some cases. Before we go into the research findings, I wanted to briefly talk about what this project, or the design of this project. This is a collaborative project. This was not, we gave them material, they implement, that kind of thing. This was a collaboration with the teachers, so they were researchers with us. And as a result, or because of that, the design was for us to identify some materials from existing various projects, or we developed some. We had a framework for the climate change, what should be the topics. And then teachers went through the materials and they helped us revise by going through the materials and telling us this is not going to work in 7th grade, this is not going to work with our students, this is where you need to redo. So we went through this revision of the materials, rewriting of the materials, revising the whole curriculum 3 times. The first year was basically trying out with them and see what they say and modifying. The second year, they implemented the modified curriculum. The third year, we went through revision and they implemented again, and then the last year was the final revision and implementation. So the second year was first implementation, and that was still pretty murky. And this is from third year data. So this time, they're a little bit stabilized, so we can look at the result and say some things. So that's the fundamental design. The other aspect of teacher collaboration was that the teachers then together planned the curriculum that they are going to teach. That means which concept after what, how much, etc. And they planned for their school. So they worked in grade level group per school. In 1 or 2 cases, there were not enough people from that school, but they still worked with a grade level group, and they had their say of what should go where. And then they shared those curricula with us, and then all the experts commented on, oh, what are you doing there? Why are you doing that there? And they revised. So that's the basic idea behind this materials or curricula that they designed and then they implemented. Okay, now to the more interesting part. Oh, before the interesting part, quickly, data sources. At the teacher level, we collected their reflection for every lesson they taught and then an overall reflection. We videotaped their teaching of the project lessons, approximately 2 weeks per teacher, but given the snow day, etc., in some cases we didn't have 2 weeks, all of the days for every week. The lessons we videotaped, we collected the lesson copies because, adaptation. We wanted to see what their adapted form looked like. And we collected some student work samples. And from students, we got content tests, pre and post, work samples from project lessons, and then interviewed 12 students. For quantitative data, we did statistical analysis. You will see what we did. Qualitative data, we did pattern coding, grounded theory. The doctoral students, if you want to talk to me about that, we can talk about that. And we constructed 2 case studies, which were composite case studies, not straight case studies. There was one primary reason for that was that we had very small number of teachers from different classrooms, and we did not want to talk about any specific teacher background because we had to mask them. And in this case, because this is a small rural community, too many people know too many people, so we could not risk teacher to be identified for IRB issues. So, to analyze the data, we had open-ended questions. So some of us, like Andy and I on physics, Dan and I on earth science, and we coded that with some researchers from the project and then, went through the typical iterations until we were in agreement. And this instrument and the coding has also gone through inter-rater reliability every year and revised every year. So that's painful. I don't think I will ever do this long qualitative or open-ended instrument with so many questions. And we are going through the last one. It has some last iteration and revision. It has some interesting data, but boy, it is painful. With 1,200 plus students over the 4 years. So, anyway. The pretest scores in the descriptive data showed some variation among the students by classroom. So we could not compare the straight gain. So we did an analysis of covariance where the pretest was the covariate. So the students, we basically controlled them by their incoming knowledge. So here is the mean and the standard deviation for pre and post test. And these are the, where is the, oh, there's the light gives me.
Yeah, it was showing up. It's not real big.
Oh, okay. So these are the number of students from each teacher's classes. These are the teacher ID. As you see, there is a gap. Teachers 6 and 7 did not complete the study. And we know who these teachers are, where they are, but we don't want to tell you that. Okay, so these are the standard deviations of their pre-test score. These are their post-test scores and with the standard deviations.
Do you have a sense of why there's such variation in the pre-test? What was the nature of the differences between these classes that would lead to such a big difference?
Could be because of the schools they were in, and because some of these are students with ELL, and also free and F&R lunch. Some schools had more diverse, minority and the disadvantaged classrooms. So in their incoming knowledge could be different. Also, I mean, this part I do not know how true it is. Some of them, we had a question asking them from where did they learn about greenhouse effect and where did they learn about climate change. And they said mostly from teacher. And in 7th grade, the teachers had not taught anything about that yet, because this was fairly early especially this year. We, as we got more knowledgeable about school things and all that, we gave the pre-test right like in the first or second week of classes. So in some cases, the 6th grade teachers have taught some climate change. And I don't want to go into the anecdotal stories of like 2 kinds of climate change and all kinds of bizarre stories. So, but there would be variation in the 6th grade teaching, and it could be because of that. Could be because of student family and home background.
So when you have teacher number 1, 87, that must be all of that teacher's students in a day. It's not just one of their classes. No. So you've not got sort of an inclusion and non-inclusion class.
Okay. The numbers are the students who gave permission, parent permission. Yeah. So it is not all the teachers of all the students. They gave it to all the sections they taught, whomever returned the form. So we really do not have. Yeah. So anyway, then do you have any idea? I really can't speculate too much other than.
I think we hit the main ones.
Yeah.
I don't know what else to say.
Okay. Ready to move on? Okay. So the gain was very significant. Everybody happy with this? Mm-hmm. Okay, let's look at more interesting data. I mean, with such a new area and where teachers taught something, I'm not too impressed with the change. And my other pet talk or pet explanation of huge changes, they taught something new, there better be some change. I mean, that was not the case for everybody, but wouldn't you expect when you teach something that there should be some significant gain? So that's not terribly important to me. So let's look at other things that I think is more interesting, or we think are more interesting. Before I go into the interesting part, as we got smarter with the test, we had questions that focused on several different concepts. So we got smarter about clustering them and looking at which ones had bigger gains. So the clusters, we named them greenhouse effect, that looked at some rudimentary understanding of greenhouse effect. Weather and climate primarily looked at how weather and climate are different, because that was a major, major problem. Even several meteorologists, one from Maryland, my friend in Maryland told me he talked to a meteorologist who told him climate model is nonsense because it does not explain the weather. So anyway, we know some other. So weather and climate, if meteorologists are confused, you can imagine what these students will be confused. So as we got smarter, we included questions specifically on that. Climate change, we had several questions on that. So basically, at a basic level, we were expecting them to understand a few things like this, because we hammered those in summer, and teachers hopefully were teaching them that. So that's the test, what we were expecting. Now, because the students of the teachers were different, schools were different, so we wanted to look at where the differences were. So we did a posthoc analysis, Tukey HSD, to compare the effectiveness of teachers. And trust me, I had to brush up all the stats I learned as a grad student. I primarily was trained in stat, as most of us in those days used to be. But anyway, I did more qualitative research later on. So now let's look at the comparison of teachers by LS square mean. Don't ask me what that is. I have to look up the formula and tell you. But anyway, it basically Tukey HSD compares each teacher with all the other teachers. So A with everybody else, B with everybody else, and finds out which teachers are significantly different than others. So let me explain this the Tukey HSD. This column. The letters A, B, C, and D, they are different than everybody else. And there is some difference between them also. E, as you see, is different from some, but not H. E and H has something common. F and H has something common. And F and G has something common. G has something common with E. So these people are more like in a continuum. These people are different than others. So, in a simple term. Okay? So, now we don't know why. I mean, we have all four of us who were in the project, we had some because we heard them talk and reflect and present every year and how they participated, but we couldn't go by that. So that's where qualitative data became useful. Before we go into what we found out from qualitative data, here are some teacher background, some things that we could ask them about without violating human subject issues. Whenever we submit a paper to any journal in Britain or international, they ask, what about the teacher age? We can't ask about those things in the US. So anyway, so the teachers, the academic area in science and related area, that means teacher had at least one degree, in some cases master's degree, in some cases extensive research experience, scientific research experience. So those are the Y teachers. And the teachers who had no N, that means they didn't have a science degree. Actually, there is one other who is kind of iffy because it was not very clear when we asked for the information. And all the teachers had pretty extensive teaching experience. There is one that is less, and I know exactly how many years, but that will identify the teacher, so I deliberately we didn't provide that information. But everybody else had pretty long experience. So this gives you an idea that experience or degree, if they matter or not. And so let's go into the cases that, the two cases that represent basically two models of teaching that we found out. The cases are composite for the reasons I told you, so there is no identifying or description of these two teachers because each one is a composite of certain type. So the top four teachers, if you will recall from the 2 slides back, that there were 4 that were at the top, were different from everybody else, and then there were rest who have several things in common. We found, without looking at the result, just looking at the other things, we found that top 4 teachers, we call them Group A, they had several common features in their teaching. Likewise, the rest had some common features in their teaching. So we constructed models from those, and that's what I'm going to talk about now. So, this is the 4 teachers from the top. These are the rest of the teachers. There are some things that were common among all of them. There were other things that were different. So, for example, broad lesson and unit topics were the same within the same grade in the same school. Not surprising. They plan together, and they typically have to follow more or less the same topics and materials. They also, on the whole, used similar things like activities, video clips, readings, but those materials were not necessarily always exactly the same, and we can't know all of that. We know some because we videotaped and we have copies. The activity structure, I call them activity structure because some researchers who study adaptation, that's what they call it. That's basically what it means. If the teacher did an activity instead of student doing it, that means they made it a demo compared to student actually doing it. So group A teachers had the students do the activities. Group B's oftentimes, especially for complex activities, made it a demonstration. And as a result of the choice, in Group A's classrooms, activities took longer time. And they were messy, a lot of things didn't work. There is a greenhouse effect activity. It is a nightmare. And Andy and I are still revising it to see if it works. And that activity, if you are in an old school, the heat duct can create a major havoc depending on which part of the school you are on. So many things to learn when you go in school. So anyway, but the teachers in this group, they kept tweaking those experiments and trying to make it work along with the students. The teachers and the students planned and tried to make things work. Group B, they did the activity. The teachers did it and told them about the outcome. The Group A teachers interpreted the data and they were messy, and as a result they taught fewer topics within the same time frame. The schools are typically, those who are familiar, they go by 9-week period. So, and these are quotes from teacher reflection on various lessons. Like there was a nightmarish graph that Dan and Deb had, and first year we almost had a revolt in classroom, then we simplified. Anyway, the graphs are still pretty complicated. The interesting thing is National Science Framework, the current framework, emphasizes students interpreting data and constructing evidence-based models. But that still doesn't happen in classrooms very much. Okay. Another interesting thing, I consider this very, very interesting. Group A teachers emphasized linking the concept. So, the conduction, major drivers in climate, and they kept coming back to that. They even created some linking days where they spent a day on making students link what they learned before. Group B, that concept didn't exist. They just taught one after another. The other thing is that all the teachers told us in summer every time that middle school students need to have some fun when they learn. Otherwise, if it is just straight science, you can forget about their being interested. So they had to let them color and do, other fun things like bracelet making and all that. But in Group A, they gave very little credit for doing that. Let them do that, but that's not the main purpose. Purpose was for students to apply what they learned. Group B gave credit for things like, major credit for coloring the folder, things like that. So that was another. There are more examples of the fun factor. Anyway, the other difference was the discourse around the materials. That means how the students and teachers interacted about the materials. In Group A, interpreting the data, interpreting the observation was a primary facet of the teaching and learning. Group B, the teacher emphasized on test. This test, any test, and teachers said that doing well on test is a major goal of learning. And they described in their reflection, I teach a concept and then I keep harping on that every day, drill it in their heads so that they have gotten the concept. So those are not my words. That's how they describe their teaching. So, quick summary. 11 teachers and 533 students from their classrooms, and 416 of these students attended schools that had majority of the students on FNR. So we saw significant improvement in knowledge. We learned that we knew climate is a complex system, but how complex and how important the feedback loops need to be in teaching, at least for me, that was like, oh my God, that needs to be, from day one, we need to harp on that. And typically, why I say not just, because that is what ended up, in some cases, being all the things they learned. Just greenhouse effect, warming effect. Students wrote about, this was, I call it doomsday scenario, what would happen if climate change happens, etc., or what scientists found out. They say, the earth will get hot, the water will evaporate, we will all die. The coastal areas will flood, everybody will move to the inland. Things like that. So a linear singular outcome type of concept rather than a varied impact. So warming is not going to be warming somewhere, cooling somewhere, warming, and all kinds of variation. There are other things like possibility. I guess it's still a possibility, right, Dan? Severity of storms and frequency, the final verdict is still out. So, drought data in Indiana, all those things were we expected, and it's not only that, more complex than that. Those are the directions for curriculum development that we learned from this, or Andy and I, more precisely. Dan and Deb knew more about these. The interesting thing is that the qualitative data sets provided us with glimpses of actually what happens in classroom and where the challenges are. The effective teaching, even though we did not focus on the complexity of the system, still some teachers were more effective and they had some common characteristics. The other interesting thing, for educators know this, but we see from the data that all the effective teachers, that is the group A, they all had degrees in, at least one degree in science. Well, everybody knows that one should know what they're going to teach. They all had longer experience, meaning everybody had more than 5 years. But those who were less than 5, they were fairly less. But in addition to they need to know how to actually deal with the curriculum materials within their context and what to change, when not to do anything. That is very crucial with these two. So neither one of these by alone does anything. It's all three are needed, because in the other group, not so effective group, there were people with degrees in their content knowledge. There were people who had long experience, but their pedagogy was not as scientific, for the lack of a better word, better pedagogy, they did not emphasize on evidence-based reasoning, student-making meaning. That's the meaning-making pedagogy, let me call it that way. Everybody has pedagogy. But that was the difference. The combination of the three was what was necessary. And we are here now working on, we have one paper out that was on the progression, how this complex system need to be envisioned in terms of rudimentary level, middle level, more complex level. Actually, it's what we are thinking now, how the system, climate system, how we need to think about that. And because climate system is very complex, 7th and 8th grade students are basically starting to learn science, because in Indiana, science is tested in 4th grade. It doesn't count. So there is practically no science teaching. And we know this because I'm out in school every semester in elementary school. So 6th grade, I think 6th grade or 7th grade, the test on 6th grade material is given on 7th grade. That's where some science learning occurs. So basically 7th and 8th grade is where they start learning. So now our next task is think about the variations that we want to see in this curriculum, more in addition to what we have done or as a next step. So I'll stop there and let you ask questions. Go ahead.
I've got one, Anita.
Okay.
I liked the contrast you did with the two different groups of teachers. Have you ruled out other potential variables? In other words, did you look at school characteristics, student characteristics of those two groups?
Yes.
To see whether those had any impact?
Yes. And no, both groups had students from this, diverse backgrounds
and things like that.
Right, and both had urban, and rural. So there are teachers in both groups who are from the same school, same grade level. So as far as we can with the small teacher size, that doesn't seem to explain. Yeah, that's a good question. That's one. I want the questions because things that I have not thought about, your questions will.
So let me follow up on that one. So in that sense, you've established that there was these two groups of teachers: those who use effective meaning-making strategies or pedagogies, and those that don't. So let's sort of, do you have an understanding of why some do and why some don't? Are there the teachers that do ones who have maybe taken part in previous programs and learned more about inquiry-based teaching? Or, I mean, clearly the implication is huge here, and so how do we get more teachers into one group and out of the other group?
I can't tell for sure, but those who have been in school for a long time, the likelihood of them, all of them, having participated in many different programs, but we can't tell if the programs emphasize that or not. There is, the reason I'm hesitating is from my NSF visit. Yeah. Anyway, I'll just tell my conversation with other reviewers, people I knew from other universities, I've known for years. And we were saying that really there is no study nationwide, and Jim and Dan will know this, they've been doing it for a long time, looking at program effect. And one of the beasts of the program effect, that programs, how can you even cluster the programs about their characteristics. So I do not know what kind of inquiry and meaning-making programs they have attended, but likelihood of most of the veteran teachers, like 10 years or more, having attended is very high. And from the conversations we know that they have attended, because there is every day this and that. So
it may not be whether they've attended or not. I mean, I remember one time doing a program with Dan, and he used the phrase serial participant.
Exactly. There are
like serial killer.
That's a good one. Yeah, that's a good one.
And I thought that was a very good phrase, and it became clear some of the participants had done many of these things before, and they were bringing a lot of skill and knowledge and experience, and often they almost were mentors to the other teachers in the program. But it sounds like some of your participants have been in 20 or 30 years, maybe have been to these programs, but have not been changed in the same way that the effective teachers have. It's interesting.
There is a caveat to what you said, because, not here, but at OSU, at that time, in my career or my colleagues, we have done many programs, and there were serial participants. I like that. But not all serial participants take it. And then there is another one, because I studied teachers there also. Some are serial participants and mentors, and when I went into their classrooms, they do mentoring very well, but in their classroom they have not changed. It's amazing how, they don't do what they do, they talk the talk, they don't walk the talk. And so there are those kind of serial participants also. And then there are who go to these things to get the money, to get the credit, get the materials, but they don't. And then they implement whatever they like to do and however they like to do. So that's why, how many projects they participated. I'm not too impressed about that. So we didn't ask about that. And yes, that is an alternative explanation. I don't have anything to refute that.
I'm curious about the testing, because your group participants are very focused on tests. Some of them are very focused on the tests. So I'm wondering whether it's the questions that's very direct answers. If you have your test would have given them like interpret graph data or something like that.
Very complex. They are not direct answers. They are like explain, draw, and there was no. In fact, next time I probably will use direct answers, because then our lives will be easier. Because every year I have to train multiple coders, and it is not.
But if you use simple tests, then the teachers who teach the tests are going to be a lot more successful. If the tests are very complicated, you actually can't teach to the test. You have to teach the capabilities that allow students to be successful on the test. So.
You can do, midway, like a lot of the national tests do. You do a multiple choice, and then you ask people to explain, and then.
But then you could look at the teachers who teach the test. Their students will be very successful in one component, but not the other. That's a testable hypothesis anyway.
Yeah,
so,
exactly.
Just a comment. I mean, the whole testing thing. Several people in the project was a biggie. They wanted to know what exactly they were to teach so that their students would do well on our test.
And because we didn't tell them, they didn't like that. There was the last round, they were and there were some teachers in the group B very vocal about not telling them exactly what we are expecting. In a sense, with the answers. Any other comment here?
I think he kind of alluded to this, and that is, I think the Group A teachers, there was a buy-in, I guess you would say, in wanting to teach the concepts and help kids better understand global warming and its impact on our climate. And the Group B teachers tend to, this is interesting. We're going to do it, but there wasn't that level of, I think, commitment on their part to the issue as the Group A teachers, and conceptually, I think the Group A teachers struggled trying to conceptualize it. But the Group B teacher, I don't think really even tried to conceptualize it.
I don't think they did. They even tried to struggle there. Any other questions? Go ahead.
I was sort of amused and intrigued by your comment early on that you did those statistics and you showed that if you do a program, students are impacted, and you made a comment about, that's actually not very impressive because, how would you do otherwise? I may be the only instance where I did a program and I demonstrated that no one learned anything.
There are some teachers. I didn't want to show you by teacher. I didn't show you the exactly teacher by teacher differences. We have graphs of gain by teacher. And some teacher.
Well, we saw one in your first table. One
you
actually declined.
I was going to say, I didn't go into that one. It actually
sucked knowledge out of the students.
Exactly. And in some cases, it was so little. So.
But what I experienced, so the first time I ever tried to do something like this was the result I got, and what I proved, what I think I convinced myself of, was not that the students didn't learn anything, but I was so bad at writing tests that what I tested wasn't actually what they learned. Right. And so that may be part of what's going on here, is that the teachers, but there's no shift in what the students perform.
This is their second year.
Is the fit between how they're teaching and what the students are learning and what you're testing. So it's the mismatch between the change that's going on in the students, because the students must have changed somehow, right? I mean, well, they could have sat there and done nothing for X weeks and really have no change. But the teachers were doing something to do with the material, so there must have been a change in the students, but not in terms of the things that you were looking for.
Yeah, and also I think what Dan was saying earlier, these teachers did something, but they didn't themselves, either not buy in and didn't conceptualize anything, so they basically passed on the materials or presented the materials. And one thing is true, 7th and 8th grade students, they really don't care unless you can relate it to their life. They're like, okay, and like teachers say, they live for the moment, and it's what party they're going to have that day, or who is texting whom, what, all kinds of interesting things. So the teacher was just presenting for the sake of fun things. They remembered that the hot solar tube flew away, and that's what they remember.
Just something, because I was looking at it, your program covers climate change, greenhouse effect, things that are more. How about applications of what they can do to, more applications, ideas like solar power, hydropower, wind power, which could be part of the curriculum to draw the students into what they can apply or what they can do actionable. Something that they can do, action points for them.
It is so complex, and we deliberately focused on content, because I guess all 4 of us thought, well, they need to understand, because this solar house, boy, I have done it, and how many times I've seen students do make the solar house, and then they can't explain what the heck is going on here. The wind turbine, oh my God, how many times? I know Dan and John have seen it many times too. Students build turbines of windmill and solar house, and so I think all 4 of us were just not interested anymore. Just build a fun thing. We were going to drive the content first, but I think I'm still focused on the content, and that could be an applications project. They did various fun projects in the classroom, so it can be a fun project, but I guess I'm a content person.
Well, I guess what I got out of the question is are there ways to link this into direct student action? So you can understand the concept, but if you feel powerless to do anything about it, it's not as important to you as if you understand the concept of climate change or some part of it and say, well, if I recycle or I ride my bicycle to school instead of taking a car, what are the things that I can do that probably aren't going to change climate change, but are in that direction?
Right. Go ahead.
My previous, I teach in Singapore, so how we did it was that they part of the maths lesson, everybody tried to incorporate it in, so they calculate in terms of emission. So how do you calculate how much will you save if you do this action and not that? And of course they had their, like you said, solar. We had the solar car race, and they calculate how much energy. So part of the school is run by solar power and things like that. So they see it taking place, and it makes it more real for the students rather than something they conduct in the classroom in an experiment, and then once we leave, it's outside our mind.
Yeah, that's a good idea. And some of the teachers did projects with the students, and we had their project reports and all that, where they looked at climate change in they chose a part of the world and they studied in their own way, and we did a project report on that. Then one of the interviews I was going to tell you about that reminded me. Some students were doing that on their own. There was a 8th grade student, and he said he and his father were going to build a green car. And I told him, I hope you are not going to drive it or try to drive it because you were in 8th grade. But so he was all about green things. So there were some students themselves who were interested. So we didn't look at that carefully. So that can be more, a more integral part of the project in future. So yeah, and we could find out about that and look at the test outcome by grouping them. There are all kinds of grouping we can still do, and we had done. I mean, our statistical analysis, and said, I analyzed, or the grad student who did it, what I told her to do, analyzed it from every possible way that you can think of. So we can do that and add that as a part of very.
Well, thank you.
Thank you.